Electrical power. Understanding electricity and electrical energy. Electricity refers to the form of energy associated with moving electrons and protons. So the energy made available by the flow of electric charge through a conductor. So these are the things that electricity refers to with respect to the test. And one thing I want to say about this electricity is we are not training you to touch or manipulate or mess with this stuff. So most of the stuff in a computer is low voltage, but it can be high voltage but low amperage, which means it won't kill you, but it'll pop you. So like we were talking about the capacitors and things like that. They'll burn you just a little bit, but not too bad if you short them, if you short your finger across them while the computer's on. And you will damage the components on the motherboard. So you don't want to do that. The other thing is, do not open the power supplies, right? We talked about that. Do not open the monitors. The little LED, LCD displays, okay, but not the larger CRT monitors. You need to be specially trained to handle that. So let's go over some terminology. We have electricity, the form of energy associated with charged particles. Electric charge, the fields generated when charged particles move in tandem, thereby producing energy. So what does that mean? So if you have a burst of electrons flowing from for whatever reason, could be lightning. So lightning flies past your head and you're holding on to a wire. So this is a piece of wire and electricity flows across this wire. You're going to have the right-hand rule applied. The direction that the electricity is flowing, you grab the arm. If it's flowing this way, you grab this way. Whichever way that thumb points is the way that the energy is going to flow. So right-hand rule, the electricity is going to flow this way. So if I have a huge bolt of electricity that flows across, I'm going to generate an electrical pulse in here. And that's what kills you from lightning, as well as if you can just be next to it and it can stop your heart. Because wherever the electrons flow past, it creates current. And then sometimes it's enough to stop your heart or literally electrocute you. It doesn't have to hit you to electrocute you. You can just be standing on the sand and then the lightning can strike a half mile away and it can still kill you. So that's electric charge. Charged particles flow once electricity comes across them. This is also why we talked earlier in a previous class about burying the wire and then lightning strikes and creates a flow of electricity. It's not the lightning flowing in there. That would destroy everything. It would literally melt the wire because it's so hot. But it's the fields that is generating, the magnetic fields that are created. When the electricity crosses a piece of a conductor of any kind, it always creates a flow of electrons. Now that may or may not damage anything. It may be small, it may be big. That's a whole separate 4-year degree in electrical engineering, right? To understand that kind of stuff and how to compute it. You can actually compute it and measure it and stuff like that. So, but anyway, that's what an electric charge is. So an electric circuit is the path taken by the electrical charge. Where is that current going to go? That's the electrical path, in this case, a circuit. A circuit is the flow of electricity. So it may go this way this time, it may go this way the next time, based on the decisions those chips are making. Electrical current, an electric charge that flows or is carried through a conductor. So whenever you have an electrical charge that's focused into an electrical conductor like a wire, that's electrical current. Current is what kills you. Voltage can kill you, which we're going to discuss in a minute. We're going to define those. But voltage can kill you because it can stop your heart, but it won't physically damage your body enough to kill you. Most of the time, a high amount of voltage will just knock you, like if you grabbed a wire that was 6,000 volts, you grabbed it, it would knock your hand off and probably throw your body in a backflip backwards. That's how strong it is. What kills you is the flow of electricity through your body, that current that flows through your body, or the charge. That is what burns your tissues and damages your body in such a way that you can no longer survive. The electrical impulses controlling your heart, your brain, things like that are broken by all of that current. And then power, the rate at which an amount of energy is used to accomplish work. So without work, we have no power. Power is a specific type of measurement. So for example, we're talking about a lightning bolt flowing through past a tree and it creates a charge and it blows something up, like a bucket of water or something. Let's say it just blows the water out of the bucket. That's not real, but let's just hypothetically say that happened. That doesn't count as power and it doesn't count as work. Those are specific definitions.